In the beginning, there was light. An unimaginable flash of energy burst forth. The Big Bang. Time and space were born in that moment, and for billions of years, the universe has been expanding, cooling, evolving, and giving birth to wonders. Stars ignited, galaxies spun, planets formed, life emerged, consciousness blinked into existence, capable of pondering not just how things begin, but how they end. Today, we ask one of the most haunting, profound questions in science and philosophy. How does the universe end? Will it collapse into a cosmic firestorm? Will everything freeze and decay in eternal silence? Or will some unforeseen quantum event erase everything in an instant? This isn't fiction. These are real theories, backed by real equations, real observations, real fear, and real awe. This is the story of the final chapters of existence, told across unfathomable spans of time. The fading of stars, the death of black holes, the collapse of matter, and what, if anything, might lie beyond. This is the end of the universe, as best as we understand it. Before we jump to exploding stars or collapsing universes, we need to understand the invisible ruler behind it all: entropy. Entropy is the measure of disorder, of randomness in a system, and it has a universal law. In a closed system, entropy always increases. Our universe is just such a system. Ever since the Big Bang, energy has been flowing from hot to cold, structure to chaos, order to disorder. Why does this matter? Because all the processes that give rise to galaxies, planets, even thought, depend on energy differentials. Hot stars radiating into cold space, gravity shaping matter, chemical bonds forming. But over time, as entropy increases, these energy differences even out. Eventually, no usable energy remains. Everything approaches thermal equilibrium. The same temperature, same energy level, same nothingness. This ultimate state is known as the heat death. A universe that has reached maximum entropy where nothing interesting can happen anymore. No stars, no motion, no change, no life. Just cold particles floating in a vast, dark expanse. And it's not just theory. It's our best prediction based on current observations and physics. But when does it happen? How long until this cosmic silence? Let's zoom out, way out, and walk through the death of everything. The universe has already lived a long life, nearly 13.8 billion years. But in the timeline of its death, we're still in its early dawn. Let's fast forward. From billions to 100 trillion years, the age of stars. For the next few trillion years, stars continue to burn, but gradually they run out of fuel. Star formation slows down. Hydrogen, the fuel of the cosmos, gets used up. The massive stars die in supernova, leaving neutron stars or black holes. Medium-sized stars like our Sun become white dwarfs, glowing embers of stellar cores. But over trillions of years, even these embers fade. The universe grows dimmer, colder. Eventually, star formation ceases entirely. Galaxies fade like dying candles. From hundreds of trillions to 1 million years, the degenerate era. In this era, there are no bright stars left, only the remnants, white dwarfs, neutron stars, and black holes. These objects drift through space, frozen, silent, like tombstones of stellar past. But even these are not eternal. If proton decay occurs, a hypothetical but plausible process, matter itself is not stable. Atoms begin to fall apart. White dwarfs might undergo black dwarf supernova, exploding due to a quantum tunneling after quadrillions of years. The number of baryons, the building blocks of matter, begins to decline. What was once solid, visible structure becomes a sea of radiation and subatomic debris. If protons do not decay, the era extends, but still trends toward the same fate. From nonillions to a Google years, the black hole era. At this point, black holes are the only remaining large structures. They slowly consume nearby remnants, dust, rogue planets. Galactic cores become empty, swirling darkness. But thanks to Stephen Hawking's groundbreaking work, we know black holes aren't forever. They emit tiny amounts of Hawking radiation, losing mass slowly over time. A black hole the size of our sun would take about 1,000,000 trillion years to evaporate. Supermassive black holes, millions or billions of solar masses, take even longer. The numbers become almost meaningless, a 1 followed by 100 zeros, and then they are gone, evaporated into faint, final bursts of radiation. No more stars, no more matter, no more black holes, just emptiness. Beyond the Google years, the dark era. The universe has no structure. It's a thin, uniform mist of low-energy photons, electrons, and neutrinos. Sparse, cold, still expanding. Time still ticks on, but there's nothing left to count. This is the end, the heat death. The universe has become a silent graveyard. But wait, what if this isn't how it ends? Our understanding of dark energy, the mysterious force accelerating the expansion of the universe, is incomplete. Number 1, the big RIP. Space itself tears apart. If dark energy increases over time, rather than staying constant, it could overwhelm all forces. Galaxies would fly apart. Then solar systems, then planets, eventually atoms themselves. Even space-time would shred, ending not in silence, but in chaos. And this could happen in as little as 20 to 30 billion years. No warning, just an accelerating spiral toward nothingness. Number 2, vacuum decay, a quantum apocalypse. Some physicists believe our universe might not be in its most stable state. That it's stuck in a false vacuum. If that's true, a quantum event could trigger a transition to a more stable state, a new vacuum. A bubble of true vacuum would form and expand at light speed. Everything it touches would be destroyed, rewritten with new laws of physics. Atoms, light, time, gone. This wouldn't even be felt. It would arrive at the speed of light. Instantaneous annihilation. And worst of all, it could happen right now, or never. It's not a matter of if. It's a matter of whether our vacuum is false. Number 3, the big crunch and the bounce. Alternatively, what if the expansion stops? Gravity could overcome it. The universe could collapse. Galaxies rushing back inward. Heat and density rise. Black holes collide. Everything shrinks to a single point. A big crunch. Some theories suggest this might rebound. A big bounce. Birthing a new universe. This is poetic, but current observations favor continued expansion. Still, in cosmology, nothing is off the table. What does it mean for everything to die? Not just life, not just stars, but time itself. For entropy to win, for silence to rule all, it forces us to ask terrifying, beautiful questions. Do our actions matter in a universe doomed to fade? Is meaning possible in a temporary cosmos? Is life a rebellion against entropy? A brief moment of order in a sea of chaos? Some philosophers argue that knowing it all ends makes the present infinitely more precious. Each moment becomes a candle in the darkness. Others see it as a cosmic absurdity, a joke played by blind physics. Still, others speculate, could we escape this fate? Could future civilizations harness black holes for energy, upload minds into simulations, or escape into pocket universes? Could the end not be an end, but a doorway? Even in a dead universe, quantum physics whispers. Particles can spontaneously appear from vacuum fluctuations. Tiny blips, cores of energy. Given enough time, perhaps 10 raised to the power of 10 raised to the 56 years, even entire new universes might emerge from nothing. This is the theory of eternal inflation. The idea that universes spawn more universes forever. Our cosmos may be one bubble in an infinite force, a single breath in a timeless storm. Maybe the end is not the end. Maybe new beginnings are coded into the fabric of nothingness. And maybe, just maybe, that's where another story begins. Science offers several theories about how the universe might end. Heat death, black hole evaporation, cosmic collapse, or vacuum decay. But for billions of people across the world, the ultimate end of everything isn't just physical. It's deeply spiritual, woven into sacred texts and divine prophecies. Islam, Qiyamah. The Quran describes a moment when everything collapses. The sky is split, stars fall, earth shakes, all life dies, and then is raised again. When the trumpet is blown, all in the heavens and earth will fall down unconscious, except those whom Allah wills. Quran 39:68. The universe ends by divine will. What follows is resurrection, judgment, and a new eternal reality. Christianity, Second Coming. Christian belief holds that Jesus will return. The earth will be renewed by fire, stars fall, and the dead will rise. The heavens will disappear with a roar. The earth and everything done in it will be laid bare. 2 Peter 3:10. A new heaven and new earth follow the cosmic end. Hinduism, Pralaya. Time is cyclical. At the end of a cycle, Shiva dances the Tandava. The universe dissolves into the cosmic ocean and everything resets. Buddhism, Impermanence. Everything is impermanent. The universe ends by fire, water, or wind, but attachment is the real illusion. liberation lies in detachment. Judaism, Messianic Age. The arrival of the Messiah brings resurrection and divine renewal. The universe is restored and made whole again. Each religion sees the end not as meaningless entropy, but as a doorway to judgment, to rebirth, or spiritual liberation. Science describes the how, religion speaks of the why. So how does the universe end? The truth is, we don't know for certain. But we know this. It will not end with a bang, but with silence, with darkness, with the slow erosion of structure and story. Unless something changes. Unless we do. And even if we don't, the very fact that we can ask these questions, that our atoms, forged in ancient stars, can wonder about their fate, that's a miracle in itself. We are stardust, dreaming of forever. We are the cosmos, briefly aware of itself. And in knowing the end, we honor the beauty of the beginning. Thanks for watching this deep dive into the depths of everything. If you enjoyed this voyage through cosmic time, subscribe to Orbital Vistas and join us as we explore the mysteries of the universe, from the quantum to the galactic, from the birth of time to its quiet end. Let us know in the comments, which theory do you think is most likely? Which one terrifies or fascinates you the most? And until next time, keep looking up, because even the darkest night sky still holds the memory of light.